go through a couple problems, you have to be able to do long division with numbers to be able to do long division with polynomials. And yes, the calculator will do this for us. The calculator will not do long division of polynomials. We can use Desmos to help us answer some questions, but it's not going to do it for us. So, whenever we're doing long division, the first number goes on the inside, the second number goes on the outside. All right, so we are thinking, how many times does 8 go into 4? It won't, right? So then we have to think, how many times does 8 go into 49? That'll be 6, all right? So 6 times 8 will give us 48, and then we'll subtract. So we are dividing, we are multiplying to get 48, we are now subtracting, which is just going to give us 1, and then we bring down. So we got 16, right? So it's the same process over and over again. How many times does 8 go into 16? 2. And then 2 times 8 is 16. We subtract, we get 0, we stop there. 62 is our answer. Okay. Now that one went evenly. Not everything goes evenly. So will the next one divide evenly? No, because if it is divisible by 5, it should end in a 5 or a 0, right? So this one's not going to go evenly. So I'm going to write it over here because I'm out of room down here. So we're dividing by 5. 5 will not go into 2, but it will go into 24. How many times? 4. 4 times 5 is 20. We subtract. We get 4. We bring down that 7. How many times does 5 go into 47? More than 6. 9. So 9 times 5 is going to give us 45. We subtract. We get this 2. Bring down. Got 28. Okay. How many times does 5 go into 28? 5. So we multiply. We get 25. We subtract. We get 3. So at this point, do we have any more numbers to bring down? Okay, we do not. So when you were first learning long division, you probably put like a R3 over here, like a remainder of 3. Later, you learned how to do this with decimals, where you put a decimal point here and put a 0 and brought down that 0 so you could like actually do it and get the decimal here. For what we're going to be doing, what I'm going to do is this is the remainder, and I'm dividing by 5. So another way that we can do this, and I don't even know if you did it like this in 4th, 5th grade or not, but that remainder, you could put it over what you're dividing by. So our answer here could be 495 and 3/5. If you keep going with decimals, it's going to be 0.6. But for what we're doing today, that's going to be the most helpful, that writing it as a fraction. So the remainder goes on top, what you're dividing by goes on bottom when you get to that remainder. Okay, questions? All right, so this may be one of the like more difficult things that we're going to do, but there are some like shortcuts and some things that can help us with it. There are a lot of questions that they're going to ask us that we can kind of figure some stuff out using Desmos, but there are some questions that they might ask you on the EOC that can only be done by doing long division. So I don't want to skip over this, even though it is a little bit harder of a topic, because I know there's a lot of you that will be able to do it. So if we are dividing with polynomials, the first thing we're going to look at is dividing a polynomial by a monomial, so something that just has one term. So just like with long division, we are going to take whatever comes first, and it goes underneath our division symbol. So we got 27x to the 6th plus 3x to the 5th plus 9x to the 4th. And we are going to divide it by 9x squared. So I like to think about the division of the numbers and the variables separately. So you're asking yourself, how many times will 9 go into 27? That'll go 3 times, right? So that's just like our normal division part. But then we got to think like, how many times will x squared go into x to the 6? That's harder to think about, right? But it's almost like you're factoring it out, like when we're doing a GCF there. So if I have 6 x's and I take 2 away, then I'll have 4 x's, right? So technically I need to put my answer, I really need to draw this line out longer. My answer goes over here above the x to the 4th, so 27 divided by 9 is 3. And then I had 6 x's, I took 2 away, so that's going to be x to the 4th right there. And I wrote it over here because I'm writing it over top of the term that has 4 x's there. So that's my division part. I need to multiply now. So 3x to the 4th times 9x squared. 3 times 9 is 27. X to the 4th times x squared is x to the 6th, which is what I was wanting to get in the first place, right? So I subtract that. I'm going to just get 0. It cancels out. And then I bring down my 3x to the 5th. This part is the hardest part. You've got 3x to the 5th divided by 9. So does 9 go into 3? It does not. But we have to have a number here. This is a little bit different than your actual long division, because we can't put a 0 there because we still have the x's that we've got to deal with. So when this happens, like here we were doing 27 divided by 9, we got 3. If I do 3 divided by 9, what is that? 1/3. Okay, that's what we're going to put here. So it's going to be plus 1/3. And then if I have 5 x's and I take 2 away, how many am I left with? 3. So we'll have x to the 3rd. And so if I multiply this back, 1/3 x to the 3rd times 9 x to the 2nd, 1/3 times 9 is just 3. And then I'll get x to the 5th here, and that will just cancel out. Also, that's what's going to happen with these monomials. And we'll bring down our 9x to the 4th. And then how many times does 9 go into 9? Once. And I had 4 x's. I got 2 right here. So that means I need x squared right here. And then that'll give me 9x to the 4th when I multiply it back. That cancels and we're done. So our answer here is 3x to the 4th plus 1/3 x to the 3rd plus 1x squared. Okay, so that's like the idea we're working with, but I want to show you a different way on these because honestly, although we're working on long division of polynomials, it's a little bit easier to do it this other way. What you're really doing there is you're dividing each term by 9x squared. So like on this next one, if I'm just dividing each term by 8a squared, that would look like this. 4a cubed over 8a squared plus 24a squared over 8a squared plus a over 8a squared. And so if I just like reduce what I've got here, 4 over 8 is 1/2. And then I've got 3 a's on top, 2 on bottom. That just leaves me with a single a on top. Okay. 24 divided by 8 is going to be 3. The a's just cancel out. And then here, this a will cancel with one of the a's here. And there'll be nothing left on top. So what do I put on top if there's nothing left? A 1. Because there was like a 1 in front of that a. So 1 over 8a. Okay. One thing we'll be talking about a lot here is that if the remainder is 0, the divisor is a factor of the expression. Oh, wait. I think I did that. It's okay. We'll talk about it on the next problem. If the remainder is 0, the divisor is a factor of the expression being divided. That just means it divides evenly. If you get a remainder of 0, then that divides evenly. All right, so let's look at some more stuff for this one. Okay, so these are going to ask us to divide by a binomial in these cases. Okay, so whenever I'm doing this, it's going to be a little bit different. I'm not going to just like divide each term by x minus 2. I'm dividing x squared plus 3x plus 5 by x minus 2. So that looks like this. I'll have x squared plus 3x plus 5. And then I've got x minus 2. Okay. So what I've got to do here, dividing is going to look a little different on this because I've got an x minus 2. So what you need to do is really only think about the first term that you have here. So our first term right there is just x. And so since our first term is just x, we're going to think about how many times x will go into whatever we're looking at. For that. The best way to think about this is to ask yourself this question. What times x will give me x squared? So what times x will give me x squared? X. So I'm going to put that right here above this term because that's where we have the just single x's. And so what I've got to do, that's my division. What times x will give me x squared? Now I've got to multiply. So when you're multiplying, what you're doing is you're doing x times x minus 2. What do you have to do to multiply that? What will I get when I do x times x minus 2? X squared minus 2x. So when I multiply, that's what I'm getting here. I want to line everything up. So x squared minus 2x. Okay? So I have divided, I have multiplied. What comes next? Subtract. Now subtraction can get a little tricky right here because you are subtracting here and then you're subtracting right here. But right here I'm subtracting a negative. So if I'm subtracting a negative, what am I really doing? I'm adding. So that really is like I'm adding. So this right here, x squared minus x squared, that should cancel out every time. If that first term's not canceling out, you did something wrong. But then I've got, here I've got to do 3x plus 2x, and that will give me 5x. And after I subtract, what do? Bring down. So I take this 5 right here and bring down that plus 5. Okay? So now I've got to start the process over again. I'm dividing, multiplying, subtracting, bringing down. All right? So when you're dividing for these types of problems, instead of thinking what is 5x divided by x, you can think that way if you want, but I like to think, what times x would give me 5x? It'd be 5, right? And it would be a positive 5, so I'm going to put plus 5 right here. Okay? So I've divided. What do I have to do after I divide? Multiply. So that means I'm taking that number I just got, 5. What am I multiplying it by? The x minus 2, because I multiply by what's out here. So multiply by x minus 2. And so we will get 5x minus 10. That goes here. Okay, so we divided. We multiplied. What do we have to do now? Subtract. So subtract this. I'm subtracting this, which means I got minus a negative again. That doesn't always happen, but it has on both of these. So really that's like adding the 10. And so now this cancels. 5 plus 10 is 15. Now if I try to divide again, what times x could give me 15? There's not an answer, because if I had 15, it'd be 15 times x, which would give me 15x. I don't want there to be an x with it, right? So this is the point where this is your remainder, okay? So our remainder is 15 for this, because we can't divide again because we're out of x's on this time. So 15 is our remainder. The way we are going to write that for these, okay, to get like our final answer, is we are going to put plus 15 divided by whatever you're dividing by, in this case x minus 2. So like if I write that answer out, my answer is x plus 5 plus the remainder, which is 15, over x minus 2. So the question says, is x minus 2 a factor of x squared plus 3x plus 5? So if I have a factor, it means my remainder is 0. Was my remainder 0 here? No. Factors divide evenly. That's the case even whenever you're a lot younger. Like 5 is a factor of 50 because it divides evenly. But 5 is not a factor of 51 because it won't divide evenly. Right? So this would be a no. That's not a factor. Now, let me show you something here, because sometimes they ask you to do this division, but they give you a multiple choice question. All right? So if they ask you to do this division, but they give you a multiple choice question, then you don't really have to divide. Because if they've asked you to divide, you could just type it in, hit the division key first, x squared plus 3x plus 5 divided by x minus 2. And that gives you this weird looking graph right here. Okay? And then graph the answer choices if it's multiple choice. In this case, we're going to graph our answer. So I've got x plus 5 plus 15 over x minus 2 right here. And so if I graph those, they're equal to each other. All right? So you can use that to check your work if it's not multiple choice. Or a lot of the questions you're going to get are going to be multiple choice where you can graph it and check. Okay? So you wouldn't have to do it in the first place. But not all of them. There's a few where you'll have to be able to do long questions there? All right. Now, the next one was, this one's got something weird about it. I've got x to the third minus 1. So typically our things are presented in descending order, where we've got like x to the third, x squared, x, and no x at all, right? We're skipping a bunch of those here, right? We just have an x to the third and a minus 1. If you're going to do long division, you can't skip those things, okay? So what we have to do for our long division here is underneath our division symbol, we'll have x to the third, but then there is no x squared, but we need to put plus 0x squared. There is no x term, but we need to put 0x, and then we'll have our minus 1. If you do not do that, it will be very difficult to line everything up, and you will probably get mixed up on the problem. Okay, so let's make ourselves a note about that. Here, if missing terms, fill in with zeros. Okay, so if you're missing some terms, you're going to need to fill those in with zeros. And then our x minus 1 goes out here. All right, so I'm asking myself to divide. I'm asking myself, what times x gives me x to the third? So, Fernando, what times x would give me x to the third? Good. X squared times x would give me x to the third. So, I've divided. Now I need to multiply. So, when you're multiplying, you're doing x squared times x minus 1, right? So you would distribute here, and you would get x to the third minus x squared. So that goes here. All right, here. All right, then after we divide, we multiply, we subtract. So I'm going to subtract. And right here where I'm subtracting a negative, it's really like I'm adding right there. Okay, so Caden, when I do x to the third minus x to the third, what do I get? 0, that's gone. And then I got to do 0x squared plus x squared. That's like having 1x squared. What am I going to get there? Just 1x squared. You can write the 1 if you want, but you don't have to. What do I do after I subtract? Bring down. So bring down your 0x. Okay? So I got to start the process over again. What times x would give me x squared? Just an x. So I'm going to put a plus x right here. That means I'm doing x times x minus 1. And so I would distribute here, and I would get x squared minus x. So that's going to go here, x squared minus x. And when I do that, now I need to subtract right here. So, Cannon, what do I get when I subtract my x squared minus x squared? They cancel, it's gone. Right here I got to do minus a negative x, which is really just like adding. So if I do 0x plus, this is a 1x right here, what am I going to get? It'd just be x or a 1x if you want to write the 1, doesn't matter. Right there. So that's an x. And then, Cannon, what have I got to do after I finish that subtraction? Bring down the minus 1. So my last step is to ask myself, what times x would give me x? What? Not 0. 0 times x would be 0. 1 times x would give me x. So I'll put a plus 1 right here. Then I'm doing 1 times x minus 1. Well, that is just x minus 1, right? So when I multiply, I'm running out of room right here. I get an x minus 1. What have I got to do now? Got to subtract it. That's going to cancel. This is going to cancel. I'm getting 0. All right, so do I have a remainder for this? No. Is x minus 1 a factor of x to the third minus 1? Yes, right here. Whenever you get a 0 as your remainder, it is a factor. And you can check with Desmos. I would encourage you to, right here. Because if we're doing x to the third minus 1 divided by x minus 1, and we type in our answer, which was just x squared plus x plus 1, I get the same graph. Right? They're the same graph, so that lets me know that I probably did this right. Okay, questions? All right, I got one more that we are going to do. I think this is on. Actually, I got 2 more that we need to do. Long division, and then I'm going to teach you a couple shortcuts for this, okay? In fact, I'm going to help you set this one up, and then I'm going to have you guys try it on your own, okay? So, this question said, what is the result when 4x to the third minus 23x minus 14 is divided by x plus 2? If there is a remainder, express the result in the form q of x plus r of x over b of x. All that means is when you give your answer, you're going to have your answer plus the remainder over x plus 2. Okay? Here. So, let's set this up. I want to make sure everybody's got it set up correctly. When I set this up, 4x to the third minus 23x minus 14 goes on the inside. Are you missing any terms? I need a 0x squared. So when you put this in here, you've got to do 4x to the third plus 0x squared because you're missing an x squared term. And if you don't put it there, you're going to get mixed up. And then so subtract 23x minus 14. And then my x minus 2 goes out front. Okay, so try this one right here. You're asking yourself, what times x would give me 4x cubed? That is going to be 4x squared. So you're doing 4x squared times x plus 2. Right? You got to divide, then you multiply. So you get 4x cubed plus 8x squared. That goes here. I think some of you might be writing that on the top. Okay? All right, after we multiply, what do? Subtract. So subtract here, subtract here. This will cancel as it should. If it doesn't, you did something wrong. And then right here, we're going to get negative 8x squared. So we divide, multiply, subtract. What comes next? Bring down. So I got minus 23x. So I have to ask myself, what times x is going to give me negative 8x squared? Negative 8x. Okay, so I've got to take that negative 8x and I've got to multiply it by x plus 2. And I will just distribute here negative 8x squared minus 16x. So we got negative 8x squared minus 16x. Okay, so we divided, we multiplied, now we need to subtract. In this case, subtracting actually becomes like adding for both of those, right? It changes the sign. This goes away. And so negative 23 plus 16 is going to give you a negative 7x right there. And then we bring down negative 14. Okay, so then we've got to ask ourselves, what times x gives us negative 7x? That's going to be a minus 7. So negative 7 times x plus 2 is negative 7x minus 14. So that goes here. What's going to happen when we subtract this time? They're both going to cancel because these just become positives. They both cancel. We get 0. So, Nate, you were right. There is not a remainder on this. This is just your answer. And I bet, Maze, were you doing it with the minus 2 like I had it set up? Messed up on the signs. It's really easy to mess up on signs on this in the middle. All right, I got one more, and then I'm going to show you some shortcuts that'll get you around this lots of times, okay? Because this is an extensive process, okay? Let's do one more, and then I'm going to show you some shortcuts. So, for this one, I've got x to the 4th minus 6x to the 3rd minus 9x squared plus 12x plus 14. There's no missing terms on that, so I didn't have to add any zeros in. And then I've got x squared minus 2. Okay? So, I'm going to have to ask myself, what times x squared gives me x to the 4th? And that's just going to be x squared. So, you've got to do x squared times x squared minus 2, which is going to give you x to the 4th minus 2x squared. Okay? So, be careful when you put this here. That x to the 4th goes here, but the 2x squared has to go underneath your x squared term. Okay? So don't put it underneath the x to the 3rd on this one. We will subtract. This will cancel. And then we basically just bring down that negative 6x to the 3rd. And then negative 9x squared plus 2x squared is going to give us negative 7x squared. And then bring down your 12x. All right, so then I'm asking myself, what times x squared gives me negative 6x to the 3rd? So it's a negative 6x. Negative 6x times x squared minus 2 is going to be negative 6x cubed minus or plus 12x. So that goes here, negative 6x cubed. The plus 12x goes right here, because you got to line it up by the number of x's. Okay. We've got to subtract this, which makes this like it's adding and those cancel. It's going to make this one subtracting, which actually these cancel too. So now, this negative 7x squared just basically gets brought down, and we got to bring down our plus 14 here. And so we've got to do what times x squared would give us negative 7x squared. That's a minus 7. So we got negative 7 times x squared minus 2. And we get negative 7x squared plus 14. This one, what's going to happen now when I subtract? They both cancel. And so we have a remainder of 0. So there's our answer. Okay, so this is a complicated process. This problem right here, there's no way around it. You've got to do long division, unless they give it to you as a multiple choice question, in which case you can type it in and see which one matches. But there is a shortcut we can use to get around this a lot of times. Okay, so that shortcut that we can use is called the remainder theorem. So the remainder theorem states that if a polynomial p of x is divided by any binomial x minus c, which does not have to be a factor of the polynomial, the remainder is the same as if you evaluate the polynomial for c, meaning to evaluate p of c. If the remainder of p of c equals 0, then x minus c is a factor of p of x. And c is a solution of the polynomial. That's a bunch of math words, right? So here's the key things that you need to pull away from that. Okay? The remainder theorem says that if you are dividing by x minus c, c some number here, so it could be x minus 2 or x plus 4 or whatever, that if you evaluate p of c, that will give you the remainder. Okay. Notice right here, this was a negative c, but over here it was a positive c. Okay. So this sounds confusing, but it is really so much easier. So if I've already lost you, if you're like, Ms. Hyatt, I will never be able to do this ever in my life. You're crazy for thinking that I can't. First of all, I don't think that's right. I think with enough time and effort, everybody in here could do it. But we do not have enough time, and some of you don't want to put forth enough effort. So, if you could not, everything we've done's made you quit, you're like, this is dumb, I can't do it. Pay attention to what we're getting ready to do, because you should be able to do it. Like, everybody should be able to do this. Okay? So, if you have a question that says, if 3x to the fourth minus 5x to the third plus 2x plus 5 is divided by x minus 5, what is the remainder? Okay? If they only ask you for the remainder, you can use the remainder theorem. This is what the remainder theorem is saying. Okay? The remainder theorem is saying that if I'm dividing by x minus 5, I can take the opposite sign of that, which would be a 5, right? So a positive 5, use the opposite sign, and plug it in. Okay? So you would be doing 3 times 5 to the fourth minus 5 times 5 to the third plus 2 times 5 plus 5. Okay? And we can use Desmos. You don't have to do that in your head here. So we would just go over here. We would type it in. 3 times 5 to the fourth minus 5 times 5 to the third plus 2 times 5 plus 5. I get 1265. Okay, that's my remainder. If we tried to do that long division, I'm not sure I'd get the right answer at the end, right? Because the numbers are obviously getting really large whenever you're dealing with that. But all you have to do is plug in the opposite sign of that factor. So we get 1265. So the remainder is 12, was it 1265 or 1256? 65. That's your remainder. So if you get a question asking you for the remainder, don't do the whole thing, right? You can. You'll get, if you do it correctly, you'll get the right answer. But it's really hard and time-consuming to get the right answer. Remainder theorem makes it so much easier. So 10 has the same function. If we take that function and divide it by x plus 2, it's wanting to know what is the remainder. So if I'm dividing this by x plus 2, what number would I plug in so I can use remainder theorem? A negative 2. Use the opposite sign. Right? So all you're doing here is 3 times negative 2 to the 4th minus 5 times negative 2 to the 3rd plus 2 times negative 2 plus 5. And you're doing this in Desmos. You don't have to do it by hand. And I'm getting negative 107. Oh, wait, no, I shouldn't. Something's wrong in there, isn't it? This needs a plus sign right there. 89, is that what you guys got? That did it? Okay, 89. So 89 is your remainder there. Does this seem manageable? Can we do this? So even if that last problem I did had you deciding that you were going to quit your math career right now, this is very manageable. Every person in this room can, without a doubt, do this with not all that much effort. Okay? So there's a lot of ways around a lot of the problems. Now, if you want to make a perfect 100, you're going to have to know how to do long division. But if you're good with a 85, 90, you can probably get by without doing it at all. Okay? The last one we're going to have time to do today says, is x minus 3 a factor of 2x to the 3rd plus 2x squared minus 16x minus 24? So, for this one, Hector, what do I need to do? This one didn't ask for remainder, but if something is a factor, what's the remainder going to be? 0. So what do I need to do to find the remainder? I'll plug in positive 3. So I'm just going to type it straight into Desmos because we're running out of time right here. You're going to use positive 3 because you use the opposite sign of whatever you see there. So we would have 2 times 3 to the 3rd plus 2 times 3 to the 2nd minus 16 times 3 minus 24. And I get 0. So my remainder is 0. And so what's the answer to the question? Is x minus 3 a factor? Yes. Okay. All right. We were going... All right, everybody stop for a second so you can hear me. We were going to have a quiz tomorrow, but we haven't got far enough with the notes for you guys to do the assignment yet. So tomorrow we will do we're going to do like the last couple things that we have here, and then we'll do the assignment. And it does mean quiz Monday, but we'll do a little review before we take the quiz. It's better than trying to squeeze it in tomorrow, though, I think. I don't think we're ready for it tomorrow.